Hi there, my name's Heinrich, and today I'm going to talk to you about Coulomb's law. Coulomb's law says the magnitude of electrostatic force exerted by one point charge on another point charge is directly proportional to the product of the magnitudes of the charges and inversely proportional to the square of the distance between them. Geez, that's a mouthful. So we're going to break it down. So what it says is when we have two charges that are close to each other, right, or even not that close to each other, they exert a force on each other. And Coulomb's law tells us how to find this force. So if we have two positive charges, positives or like charges, so a positive and a negative, repel each other. They push each other away. Similarly, if we have unlike charges, a positive charge and a negative charge, they attract each other with a certain force. They pull each other closer to each other. Right. So the first part there says there's electrostatic force exerted by one point charge on another point charge. Right. But Newton's third law is important here. So the blue charge, right, exerts a force on the orange charge. But that orange charge, due to Newton's third law, exerts exactly the same force on the blue charge. It's just in the opposite direction. So the two charges both experience the same force, it's just in the opposite direction. So the next bit there says directly proportional to the product of the magnitudes of the charges. So all that means is the bigger the charges are, right, the greater the force is. Bigger charges give bigger forces. Smaller charges give smaller forces, i.e. they don't pull or push each other away with as much force. Let's move on to the inversely proportional to the square of the distances between them. So all that means is the further the two charges move apart from each other, the less the force is that they exert on each other. And the closer they get to each other, the more or the greater the force is that they exert on each other, right? So it is the square of the distances between them. So if you increase the distance between them by a factor of 2, you decrease the force between them by a factor of 4, right? Because it's a squared relationship. If you increase the distance between them by a factor of 3, you decrease the force between them by a factor of 9. So the further you move these things apart, the force starts to drop very, very quickly because it is a squared relationship. Right. So then we find that we often have problems that's got more than two charges in the same space, right? So here we've got three charges, and the question might be something like, find the net electrostatic force experienced by B, the middle charge there, due to the presence of A and C, right? So we know that A and B both experience a force due to each other, but B and C are also reacting with each other. So B is experiencing a force due to A, and since it's a positive and a negative, there's a force of attraction, right? So B has a force to the left, and B and C is also experiencing a force, right? So C is pulling B towards it, so B also has a force going to the right. So our little system here is first we're going to do one thing at a time, right? We can only do one thing at a time. So we're going to find the force that A exerts on B, right? Then we're going to find the force that C exerts on B, and those two are both easy things to do. We just apply Coulomb's law to A and B, and then again we apply Coulomb's law to B and C. And then all we're going to do is we're going to add up the two forces to find the net force that B is experiencing. But remember, force is a vector. So when you add them up, you have to take the direction into account. So B is experiencing a force to the left and a force to the right. So if left is positive, right must be negative. So the force to the left is going to have the force to the right subtracted from it. Okay, so make sure that when you work with these forces, you take into account that they're vectors, and you make sure that you add the correct things or subtract the correct things based on what you've got in your diagram. So 3 is easy when they're in a straight line, but what if they're at an angle? So it looks a little bit complicated, but actually you already have all the tools you need in order to answer this question. So again, we've got a charge that is experiencing a force due to 2 other charges. So your first step, again, is to find the force that one charge is experiencing due to the other charge. So that's one calculation. And then your second calculation is to do the force of the other 2 charges, right? And then you've got the middle charge, the orange charge, that's got 2 forces acting on them. And again, when we have 2 forces, we can add them up in order to find a net force. But adding them up gets a little bit more tricky because they're not in the same plane. They're not either in the same direction or directly opposite to each other. So how do we do this? We have to find the resultant vector drawing a vector diagram, right? So what that means is to add the 2 vectors, all we're going to do is we're going to draw them head to tail to form a triangle. So again, vectors, we have to add them head to tail. So 2 arrows can't be looking at each other and 2 tails can't be looking at each other. You've got to put it head to tail. Then all you do is you draw in a hypotenuse to your triangle, and that is the resultant vector. That's the 2 added together, and you've got a right-angled triangle. And whenever we see a right-angled triangle, we get really happy because we can apply Pythagoras. So in order to find that hypotenuse there, you're going to use the value you found for this vector and the value you found for this vector, and those are going to be the values of your 2 sides of your triangle. And once you have your 2 sides of a right-angled triangle, you can find the hypotenuse simply by using Pythagoras. And there you go, you have got the resultant force. But it isn't as easy as that. Well, it kind of is, but not quite yet. So forces are vectors, and vectors have magnitude and direction. So now we have magnitude, we used Pythagoras to find that, but we don't yet know how to say what is the direction of this force. So what we do is we put an angle in that triangle there. Right, so we've got a theta there, and it's the angle between the vertical force and the hypotenuse. So once we have an angle in a right-angled triangle, and we've got sides, we can use trigonometry in order to find the size of that angle. So here the easiest to use is just tan theta is equal to the opposite over the adjacent. So tan theta is equal to this side, or that force, over that force. And then you can just plug it into your calculator in order to find theta. And once you've found theta, you can say this force is at a so-and-so degree angle to the vertical. And there you go. You have found a direction for your force to go with your magnitude, and you've completely answered the question. So that is Coulomb's law in a nutshell.